Okay.
No.
So this is chapter 7. Make sure the sound's working. Okay, so chapter 7. These are higher order derivatives. We're going to start looking at more complicated functions, not just polynomials and quadratics and quotients and stuff like that. We're going to be looking at things like logarithms, trigonomic functions, inverse trig functions, all that sort of stuff. The first one we're going to start with, and exponents. 7.1 is all about logarithms or atoms. Logarithms. Okay. So you guys took logs in pre-calc 30, right? Okay. So we kind of have a basic understanding of how logs work. We're not really needing to know that. We know the basic shape of their graphs, right? Well, logs do something like this. Okay. The reason the only reason I'm bringing this up is because remember, what does a derivative do? It finds the slope of the tangent, so you can find the slope at any point along here, right? But that's all that we're trying to do here. Now, with logarithms, some of them can be quite complicated, so it does definitely help to remember some of your logarithm rules when you guys did simplifying of logarithms. Like addition was multiplication, subtraction is division. If you have something up front, that's the power, right?
Sure.
So let's quickly review log properties. So let's say you have the log of something. And they're being multiplied together. You can actually write them out like this. Plus log b. That's what I mean by that is, for example. This is more pre-calc 30 stuff, but just so log 70 can be written as log 7 plus log 10. Because 7 times 10 is 70, right? So multiplication and addition. You have division. We remember that as, right. Does this look kind of familiar?
Yes.
You guys would have covered, you had to have if you did logarithms at all to simplify or anything like that?
Yeah. Yeah.
Okay, yeah.
Yeah, we kind of blocked it out.
That's fair. Logs are the one that everyone stresses that you should know the most of or remember, but it's always the one that people struggle with, so it's always the one that kind of gets left behind. You have log A to the power of B. You can rewrite that as B times log of A.
Was that like C, Y, log? No.
I think you're thinking of this one here. You have whatever log, and it's always to a base. Whenever, like if it's just log by itself, it's log base 10.
Yeah.
Just like if you see this, it's actually square root. We just leave the number out because it's implied. So the base could be anything. It could be log base 2, log base 3. So whatever the base is, like log base u to a, you can rewrite that as log base 10 of a divided by log U.
That's not what I was talking about.
Oh, no?
It's like it can make it into exponential, like from a log.
Oh, going back and forth?
Yeah.
Yes, you can.
That's what I thought you were talking about.
No.
Okay.
So, like, for example, if I wanted to know what log base 3 of 7 is, your calculator only does log base 10. So what you could actually do is this. Take the log of 7 and divide it by the log of 3. And it'll give you the answer. Okay? Yeah. Sure, if you're stuck on a question, just move on. I got a spiel here. It's gonna take a little bit. If you want, the word problems are all just ones you use your Desmos for, okay? All right, now. So now that we remember those, I'm not gonna sit here and go through them all. I'm hoping you guys kind of remember some of this stuff. Cool. Like other things of logs, like whatever the base is, you always try to write out what you're entering to that base as well. And then whatever this exponent is, that's your answer. Okay, so for example, log base 10. I'll write the 10 in this time just so we can see it. Let's say, and we want to take that of 1,000. We know.
Oh yeah.
Okay, we know 1,000 is 10 to the power 3. So the answer to this is just 3. Right? Yeah, and they're inverses of exponents. I'm not going to write that out because that's just, everyone struggles with that. And we've been like, oh, wow, does it work again? So we'll leave it there. Yeah, there we go. All right, and scene. Enjoy your week. Okay, now let's talk about the derivative of logs. Textbook uses U, so I'll just stick with that. So log to whatever base U, okay? I shouldn't have time. Log base B, use the entry in there, okay? The derivative of that is this here. Y prime would be whatever is in here, the entry into the log, you put the reciprocal of that. Oh yeah. Times log is the same base. Yes. Log base B. Now, I wonder if we talked about this. Have you guys talked about this? If I drew in log base B, but it's not with the entry U now, it's E. Did you guys talk about E in pre-calc 30?
Like, I think you mentioned. It, but we never used it. Isn't it a const?
Yeah, it's a it's just like pi. E 2.71.
Yeah, we never actually used it, but you talked about using E.
Yeah, you use it now. Congrats. And you don't really use it, it's just a constant that you put. It's just like pi. 2.71 or 2.72, depending on your calculator. It's just log E times the derivative of du dx. So whatever this is, you take the derivative of it and you times it at the end. Okay? Let me show you what that looks like.
Yeah.
Don't worry, it's not like, okay, now you got it. Yeah. Do questions 1 to 20 odd. No. I wouldn't do that to you guys. So what this looks like, let's do an example. Let's go f of x equals log base 2 x cubed. So f prime would be 1 over u right times log to the power 2 of e. You just leave it as e. Don't put 2.71 in. Don't put this into your calculator to figure it out. Just leave it like that. Okay, you don't have to do anything to it. Just leave it alone. Times the derivative of this one. How's that sit? You sure, Leah?
I think so.
You look kind of shell shocked. I don't know.
I think I'm good.
Okay. My personal opinion, logs are the hardest ones, just so you guys know. Let's start off strong. Okay.
Like logs and exponents.
I'll do logs today, exponents on Tuesday,
Jesus.
sine, cosine, tangent, secant, cosecant, cotangent the next day. Those ones are easy. Those ones are easy. The trick is just keeping them straight. Because like the derivative of sine is cosine. The derivative of cosine is negative sine.
Oh,
Oh my god.
Derivative of tangent is like tangent or secant squared.
oh.
So you just got to remember that.
It's not like that stuff that we did that we did like groups. Yeah.
No. There's no identities.
Okay.
Yeah. No.
That was terrible.
Now, I don't know what people hate identities.
Because they're stupid.
They're fun. They're just puzzles. If you want, you could rewrite this because it's all being multiplied. You go like 3x squared. Like that. X squared over x cubed. These would just cancel. So then I just have 3x. How are you feeling? Not bad? Let's try another one. 12 log, what's the base on this one? Base 7 x squared plus over x. So whenever you have a constant here up front, just leave it there. You don't do anything to it. You don't have to like make it a power. You don't have to take the derivative of it. You just leave it there. What's up?
Q with the leading coefficient.
Well, if it's the number, right? If it's a positive with a parabola, it opens upwards. If it's a negative, it opens downwards. If it's linear, it goes this way. If it's cubic, it does this. If they're negative, they go this way. Go down like that. Okay, it's 6.1. Check your notes, okay?
No, I'm looking at it right now.
Yeah, so it's the first number in front of the highest power. All right? So, come on, Brooklyn, you got to try.
Yeah, I am.
All right, so the derivative, the 12 just stays the same. All right? I put this all on the bottom. Right? Times RV. And then I take the derivative of the inside.
So it 12 stays in front the whole time.
Yep, it's just a constant out front. Okay? Like what you could have done, like technically this out here, according to our rules, if you remember, this one here, I could have rewrote it as a power, but then you're going to do the chain rule, and when you do the chain rule, you still get a 12 out front. So it doesn't matter what you do.
So it doesn't go with the log, it's its own thing.
Well, technically this is all one thing.
But it
Yeah.
doesn't stick to it?
Yeah.
Okay.
Yeah, you can move it around. Okay. Now, we can simplify this a little bit. If you want, you can rewrite 12 times. I'm going to bring this guy over here. I can take 2 out of all that. I can take an X out of all this. Oh, that's fine. Yeah. Then 2 times 24, or 2 times 12 is 24. Notice I never do anything with the log 70. How are we feeling? It's weird. It's different. That's your answer.
Okay.
Because technically this is log base 7, 2.71, whatever your x is going to be. Okay.
Yeah, hopefully. No, hopefully.
Okay, do one more, then we'll do natural logs. Now we're going to get tropical. So for this one here, you bring it out, take the reciprocal of it first, right? So write that out. Let's see here. These are positively coefficients of the quadratic. Negative. Positive. Negative. Oh, y is less than 0. So y is greater than 0. Where do you see where your y's are never negative? You have no negative y values. Negative. Okay? Does that help, Wick? Okay, if you're stuck on that, go to the word problems because you can use your decimals, okay? All right. So, first part, you take the reciprocal of the first part, put it over 1. So if you just flip this, dy dx, x squared. Right? Kira?
Yeah.
Good. Log 8 e. Right? Now, quotient rule that one. Yeah, right? F prime, G prime.
Yeah, can we
No, don't do that. Then you got a negative. It's so gross. Quotient rule is so nice, you guys.
That was ugly.
6 prime. Okay, now I'm going to put a pin in all this right here for right now, because I can't do anything to it. I got some algebra that I can do right here, though. Algebra. Okay, so I'll do my distribution, do my FOIL. Okay, so 6x squared times x squared becomes 6x to the power of 4 plus 18x squared minus 4x to the power of 4. That's the top. Everyone's okay with that?
Mm-hmm.
Yep.
Is positive right or left?
Positive is left to right. Yes. I'm not going to do anything down with this here. I changed my mind. So remember the golden rule with the quotient rule? Leave that alone. Okay, don't overcomplicate it. I can combine these. This. 2x to the power of 4. Now the last thing I'm going to do, hopefully, is I'm going to take a 2x squared of the both things on top. Okay, so that's simplified. Now, what the heck did I have over here? Log base 7e?
8.
8? Whatever. Normally I never do bases, I always just really write as logs. X squared to the power of 3. Or x squared 3 times 2x cubed. Oh, look at that. Now, you can rewrite it again and then see how this stuff cancels, or you can just look across and see like this. It's like that. Wild. So this will go, that'll go, and this is kind of like that. So this will go, that'll go, this will go, that'll go. So they would write it out as, yeah, just like that. So what they do, you can, it doesn't matter which way you put it. The textbook, I would always put it over here, have the log stuff first, but the textbook puts all the x stuff, then the log. 6 in one, half a dozen of the other, doesn't matter. My textbook, yeah, whatever. Do it my way. Now, I'm sure you guys all see the patterns that are starting to arise here, right, after this first time seeing it. Do you really see stuff, Bella, or are you just agreeing with me to be nice?
Kind of agree.
I appreciate the honesty.
One,
Like with the quotient rule stuff, what I like about using the quotient rule here is you're always gonna, whenever you take the reciprocal and then put the bottom piece and square it, you're always gonna have something to cancel there. It always kind of works out nice like that. And then it looks ugly, and then that's not so bad.
So like taking a derivative of logs, you'll usually have stuff crossed out.
Yeah.
Like the base case.
Yeah. Yeah. And from what I remember, I think the textbook does more logarithm stuff than I remember from university, and then does less trigonometry stuff than what I remember from university. They kind of balance it that way, differently. But this is kind of it. Oh, wait. But that's how it works. Does anyone have any questions about that? We're all okay putting that E in. We're not freaking out. Okay, good energy in the room right now, guys. I like it. Next one, natural logs. These are logs to base E. All right, like log on your calculator is to base 10. This is to log base E. All right. You should have a button on your calculator for this, too. Now, normally I would take a little more time and go through explaining what's so important about natural logs and base E, but I just don't right now. Okay, so you'll learn more about this in university. Is there a way I can condense this and quickly explain it?
Probably not.
Yeah, so it's just based on the slope. It's a special slope at 1 that you worry about. They'll go over it in like 10 minutes in university, and you're like, I think I got it, cool. And you don't worry about it. You do more natural log stuff than you do log stuff in university. So what we do, so basically, it's log base E, but what they write it as is they go ln for natural log. Okay. So the big property, all those properties you learned about logs up here still apply. I don't know where they went, but they're there. But big thing to remember is if you take natural log of E, it just equals 1. All right. If you took the natural log of E to the power of 8, any takers on what that's going to equal? 8. Yeah. It's whatever the base or the exponent is. That's E to the power of 1. Right. It's a fair guess, though.
0.
No, that's ridiculous. Okay, so that's how those work. And now the derivative of a log. So reciprocal of x, okay, just like before. So it's log or just then just the derivative of x. Okay, so you take the derivative of the function. Okay, so with logarithms, you would take the reciprocal, put log base whatever to E, then the derivative. Here you just do reciprocal times the derivative. There's no ln E or anything like that you put in. Okay? Yeah, let's do some. How's everyone feeling? Is it like Monday or something? You guys are like, yeah, it seems like everyone's dying here. I'm going. Does you guys got a bug?
Yeah, it's one of I'm in pain from my sunburn. My scalp is burnt. I can't move.
You burn your scalp.
I actually did burn the back of my calf a little bit. I forgot to apply.
Me too.
Or missed a spot.
But like I can't touch my hair without my scalp just going.
Oh, that sucks. So funny, but not funny. All right. Let's not do the easiest one right at the hop. Let's do one a little bit harder.
I think we should do the easiest first.
You guys will be fine. Okay, so that 9 out front is just a constant. Like the example we saw before, we just leave it alone. All right? If here, don't touch it. I know you want to get rid of the 9 or do something to it. I mean, calculus this thing, but you don't. So I'm just going to this. 9 times the reciprocal of this times the derivative of the inside. No logs. Right? Yes. Because remember, what do you put in for the entry for log? It's like log base 7, and then what do you put in? E. So if we did log ln E, what does natural log of E equal? 1. So there's no. Okay, so we don't do that. And that's the answer. These ones I like way better. Well, we just did a very easy example to start with. But you know, for whatever reason, it even trips me up. I think it's more psychological than anything. As soon as you have to do log base something to the power of E, it just makes it look way harder than it actually is. All right, I've told students in the past, if you're doing the exponent or taking the derivative of a logarithm, do this part first and then put the log base E at the very end. Because then, for some reason, it's easier for people to work with. All right, now that we're feeling good about this, because that was easy, let's do a hard one. Okay, let's do a product rule. You guys like the product rule? Yeah. And then we'll do quotient rule, or chain rule. 3x plus 2 times 2x plus 1. Put that on the bottom. I don't know why I did that. So remember, I don't know why I had to put the bracket around it, but I just felt the urge. So that's the product rule, remember? So it's just going to be right? We're all okay with that? Okay, now I'll do some distribution, and I'll combine this stuff. And then I'm not going to touch the bottom, leave that alone, but I'm going to do like this, or this. Okay, so it's going to be 6x plus 3 plus 6x plus 4. Add it all up, 12x plus 7 plus 2, 2x plus 1. Boom. Done. All right. For that one, this one's done. That's the answer. I'm not going to simplify it any more than that. I can't take a common factor of 12 and 7 anyway, so. Let's see here. How are we doing? Okay, half an hour. Okay, we're there. Okay, I'm going to do 2 more. Oh, I care. First one, where'd you go? Natural log of the cube root. So write the reciprocal down first. then times it by the derivative. Chain rule. Okay,
I feel like I had it right the first time. Okay, but is this
yeah.
Okay, so that's what I thought. So then, but I tried both ways, and either way it's linear.
What's that?
I tried it both ways, so either way it's linear. But what does it mean for mean and range? So that's for like A and B values.
Your x and y values. Can you have any negative values? Can you have negative shirts or negative money? No, so everything has to be greater than 0.
And you're just leaving like root 3.
All right.
and then we have to times it by the chain rule of that.
So then there'll be 1/3. 6. Yeah.
What's 6 times a third? Because this is a negative, you could leave it like that, or because it's a negative, you can drop that down and make it positive. So then it becomes, this one is to a negative 1/3, right? We can agree on that? Or it's positive, sorry. Because it's on the bottom. We don't have to make it as a negative because it's already on the bottom. Right? No, because it's already on the bottom. If I brought it up top, then it's a negative. That was my bad when I said we can agree on that, right? Mm-hmm. And then I was totally wrong.
We don't find this stupid.
Yeah, thank you. You guys just blindly follow me. We can all jump off this bridge and survive, right? Mm-hmm. All right, let's go.
If you told me, I probably would.
Please don't, Amory. Don't ever do that.
So if you tell us to jump off the bridge, we'll go through it.
Okay, I'll have to remember not to do that. With great power comes great responsibility. All right, now.
Last class, they could blow stuff up, but anything else they blow up, just don't tell me about.
Exactly. Now, what's the rule for multiplying? What do you do with the exponents?
Like,
Add them.
one video.
When you're adding fractions, what do you need?
Wrong denominator.
Do I have a common denominator? Yes. So this is 1 plus 2. 3. 3 over 3?
What? That was whoa.
There's the answer. There's the answer.
Is that the answer?
I like that question. I love it when it just it's nothing in the end. It just simplifies so nicely.
Do you know what's funny about these videos is that if someone watched all your videos, they'd know exactly what kind of person you are.
Yeah.
Yeah, probably. I give a lot of information away in class.
You do.
Speaking of the answer is 0, what's the derivative of this one? It's natural log 2.
Is it 0?
Yeah, it's 0. Because it would be 1 over 2 times what's the derivative of 2? 0. Just so you guys are aware. Okay? Because 2 is a constant, right? So the derivative of any constant. All right. Now, just for hoops and giggles, let's try one.
If I could yell at those.
Stretch this one. It's going to take a lot of power. 3 now, and
Yeah, I'm pushing. You can squish it in. I am.
This is gonna take like a lot of room.
no, I don't think so.
I'm not putting it over. I refuse.
Okay.
Just kidding.
Oh no.
Oh no!
Oh my.
I probably wouldn't put one like this on the test.
That's good.
but you would definitely see this in a Math 110 textbook. So just walking up here.
I'll get them not taking that one now.
You're taking like Math 200. 3 is the easy part, right? We just leave it alone. Now, remember, next part is you take the reciprocal of the inside, right?
Yeah.
Because we got to do the derivative of this guy, then we have to do the derivative of this one. Okay? So, okay. Now, we multiply it by the derivative of the inside, right? So the derivative of the inside is the reciprocal of this times what's the derivative of 4x plus 9? Hey, we did it.
That's it?
Yeah. We took the derivative of the outside. Yeah, and took the derivative of the inside. So now you just kind of work it out. It's going to be 4 times 3 is 12. Now, this question comes up. Does it matter if it goes 4x plus 9 times natural log 4x plus 9, or does it have to be natural log 4x plus 9? So basically, could I switch these two around? Well, no, because one's logarithm, natural log of the number. This is something different than this. But does it matter the order?
No.
Why not?
Oh, because it's 0.
No, not quite. Does it matter if I write 2 times 3 or 3 times
Oh,
2?
no.
No, it's multiplication. You can put it anywhere you want.
Because the answer is 0, that's why. 4x plus 9 squared.
No, this is something different. That's the natural log of just this here. So that's its own independent number. Okay?
So if like those two numbers were something like 4x plus 9 and like 3x, you couldn't switch that because it's.
Oh, no, you totally could.
Oh,
Yeah, just as long as the logarithm sticks with the number that it's with.
okay.
So like if I had logarithm 3x times x plus 2, I could switch it and go x plus 2 times.
Just as long as.
Bingo. Yeah. Okay? How are we feeling about day 1 with higher order derivatives?
This is so weird.
You have to remember like product rules, chain rules, your rules with exponents, and sometimes, not all the time, remembering things like the rules for the logs that I went over can be helpful.
I think that's gonna be my downfall because I do not.
Like like you're not wrong. Like let's say I gave you take the derivative of log x squared plus 2 divided by 3x plus 1. Doesn't matter. You could like do the chip product rule or the quotient rule for all this, or you could even rewrite it as and take the derivative of each part separately. Technically, they're both the same thing. Okay? So depending on what you want to do, you can do either or. Okay? All right. Good vibes, good energy. I like it. There they are. All right. Eight, 9. Kid. Or this smells up.
Is that really different?
Could be yours.
Is there a way where... Okay, I'll just text it. Oh, I'm sorry. Oh, it's okay.
I think it just goes up.
I hear about scaring the crap out of the construction guy.
Did she?
Yeah, she was hiding
By the water
by the
fountain.
water fountain, like in between the wall and the water fountain. She like leaned out and scared the crap out of him.
Doesn't she have a job?
No.
Yeah.
What do we pay her to do?
She's emceeing our banquet.
Is she?
Yeah, because Heath and Johnson backed out.
Did they really?
Yeah,
Those guys.
I know.
That's so important.
Oh, yeah. No, that's alright.